Hello and welcome to this week's STEM lesson. This week we will be discussing energy. Energy can exist in different forms. Most forms of energy can also be classified as kinetic or potential energy. Energy is the ability to do work. Another way to say this would be that energy is the ability to cause change. Work is done when a force is used to move something. When work is done, energy is transferred. This transfer occurs between one object and another. For example, a batter swings a bat and transfers energy. They transfer their energy to the bat. The moving bat, in turn, transfers energy to the ball. Energy is measured in units called joules. Energy exists in many forms. One form of energy is called mechanical. Mechanical energy is the energy of motion. This type of energy can also include things that are not yet in motion. In these cases, they have only the potential to be in motion. In most cases, this ability comes from a position. A rock sitting on top of a cliff has potential energy. It is more than just the ability. A rock sitting on the ground could move if someone picked it up. This is not the type of potential energy we are referring to here. A boulder sitting on a cliff may get pushed loose. The natural force of gravity will pull it down because it cannot stay hanging in midair. This is far different to saying a rock may move because of a random event. Therefore, it has the potential to be in motion. Another way to store energy is by changing an object's shape. If you stretch a rubber band, it is storing energy. When the rubber band is released, the rubber band moves. Kinetic energy is the energy of motion. Anything that is moving has kinetic energy. This applies to atoms as well as to planets. Things with kinetic energy can do work. They can cause change. For example, if a hammer is used, it is doing the work. It is pounding a nail into the board. In other words, the hammer is causing a change by moving the nail. As you can see here, it has potential energy that changed into kinetic energy that is now mechanical energy. The amount of kinetic energy in a moving object depends on its mass and velocity, which velocity means its speed. An object with greater mass or greater velocity has more kinetic energy. In many parts of the world, trees lose their leaves in autumn. As the leaves are falling, they have kinetic energy. While they are still attached to the trees, they also have energy. When they are attached, they are not in motion, so how can they have energy? Instead of kinetic energy, they have stored energy. This stored energy is called potential energy. An object has potential energy because of its position. For example, leaves on the trees have potential energy because they could fall. They fall because of the pull of gravity. Potential energy can be transferred into motion. Objects have potential energy due to their position. That leaf on the tree branch still had that potential energy. The leaf's energy can be turned into motion as it falls. Once the leaf is on the ground, it has no more potential unless it's lifted back up. Gravitational potential energy is affected by position. Like the leaves on the tree, anything that is raised up has the potential to fall. It has potential energy. Gravitational potential energy depends on two things. It depends on its weight, because a large falling rock can do more damage than a leaf falling from a tree. It also depends on its height above the ground. Like a skateboarder, the higher the ramp, the faster he will be moving when he reaches the bottom. Like all energy, gravitational potential energy has the ability to do work. In this case, weight has the potential to deliver a force. More important for us is that it has the ability to cause change. What kind of change, might you ask? Gravitational potential energy has the ability to cause motion. Now, another type of energy is related to its shape. This energy is called elastic potential energy. This energy results from some objects are stretched or squeezed. For something to be elastic, it must have the ability to return to the same shape. For example, a rubber band has been stretched. Will it spring back to its original shape when released? Yes, of course it will. So what would happen if a diver jumps off the diving board? His gravitational potential energy changes to kinetic energy as he falls. In other words, he falls faster and faster until reaching the water. However, he can always regain his potential energy. All he must do is get out of the water and climb right back up. This requires an input of kinetic energy. These changes in energy are examples of energy conversion. These changes in energy are examples of energy conversion. Energy can be converted from one type or form of energy to another. Energy often changes between potential and kinetic energy. Energy is always conserved during energy conversions. Now, again, as you can see here, we went from potential energy to kinetic back to mechanical. Down here we have an arrow drawn that has potential energy, but it does not become kinetic energy until it is released. Now, you've probably heard the saying, what goes up must come down. This is one way of explaining conservation. The same idea applies to energy. Potential and kinetic energy are always equal to the whole. As one type of energy increases, the other will decrease. You never have more than what you started with, and you will never have less either. In some situations, energy can be used to overcome friction. In these cases, the energy is converted to heat. Have you ever rubbed your hands together to make them warm? That is a form of energy conservation. The energy of rubbing your hands together is not wasted. That energy is turned into heat energy. Now, I hope you enjoyed today's lesson, and thank you for watching, and we'll see you next week.